So now, I'm talking about now the concept mapping using the Octopus technique. I think you are ready for that. So now, when you're using the Octopus technique, and of course you are, for those watching us live from YouTube, of course, you can be able to get from there. You can also be able to, my technical team will also post the link for the Zoom and the YouTube, but of course, I think we are all clear. Those guys, those are also following on technical team in the YouTube. You can also bring out if there's any question that is being asked from the YouTube live. So with the organic qualitative analysis using the Octopus technique, I know most of you, if you have used the top-notch book 4 and Octopus, you should have looked at that. So when you talk about the organic qualitative, the organic analysis Octopus, you look at the, you look at the reactions. What are the reactions of alkenes? What are the reactions of alkenes? You know, we have hydration, we have hydrolysis, we have addition reactions. We have addition reactions whereby we are reacting with the chlorine. We have reaction with hydrogen, reaction with hydrogen halide. The addition reactions are those ones. And it's very much important for you to understand that addition reactions for alkenes and alkynes, they are simple reaction with halogens and reaction with hydrogen halides. As when we go to the proper analysis, you'll find that many students, when they are told like ethene is reacting with the HCl or is reacting with the chlorine, they start talking about chlorination, bromination, iodination. Those terms do not give you any mark. So we are talking about, we have fermentation, we have dehydration, we have alkanols, we have like alkanols, we have reaction with metals, reaction with the test for ROH. We also have comparing the chemical and the physical properties of organic compounds. For alkanols, we have combustion, we have oxidation, esterification, dehydration. We have substitution for alkanes. We also have polymerization, detergent, and all those kind of things there. So it's very much important for you to be able to get to that. So let me now take you through. Let me take you through now the organic qualitative, organic Octopus technique. Now this is now Octopus question model. That's why I said after now you have done the revision, you have revised the notes. Now you can come and deal with now the Octopus revision model. I want you to breathe in and breathe out because I'm going to now take you through. This flowchart is everything. I'll take you through. I'll also post the answers for each, the questions and answers for each of these questions later. I'll also be able to put maybe something in the YouTube, and I'll also be able to put I'll also be able to post the answers for these particular questions in my Twitter handle. So make sure that you follow it up from there, and it's going to be very easy for you to be able to understand. So let's start. Are we there, students? And are you able to get me clearly? Because if you revise these things properly, you are sorted. Students, are you there?
Yes, we are.
Yes.
Yes.
So now we are ready to swim with the octopus in the deep sea. Now, let's start with reaction number 1. This one is summarizing both organic 1 and organic 2. So this reaction 1, I want us to go to, but later I will also be able to post. I'll just be able to clarify the issues. I want any issue that you find confusing. Where's Mr. Karane? Are you there?
Yes, I'm there, Mr. Mbaluka.
Please be able to check on the chart so that we are able, and I think I've not made you the cost. Let me give you the superior power so that you can.
Thank you, Mbaluka. Thank you.
So who else is there? I think now make sure that you're able to get that. Bring out attention to any issue that you think is very necessary. So Mr. Karani is a distinguished chemistry. chemistry teacher and chemistry expert with an authority in that. And I know that when he's here, I'm sorted in terms of the chat. So if you have a question, make sure that you post it there. Mr. Karani, you find something that is a little bit confusing, or rather we already know the issues that students have, so that we can clarify it if need be. So thank you, and let's move on. We have conversion of ethane to ethane. Normally, this question, in many times, the examiner will give it as a process. Will give it as a process. He can call it process, whatever. So many times you find it being named as a process. So whether it's called a process or it's a reaction, the name for that one is called what?
Hydrogenation.
Hydrogenation.
I'll be able to explain what is normal hydrogenation, and the reagent there is what?
Hydrogen gas. Hydrogen gas.
And the condition is
Presence of nickel catalyst.
nickel
catalyst.
200 degrees Celsius. At 200 atmospheres.
250, any, but just give specific. Just give any temperature within the range of 150 to 250. You can talk about temperature of 170, temperature of 180, temperature of 200. Okay. So in any reaction, be able to know the name of that process or reaction. Give us the reagent. Give us the condition. You are sorted. Now,
Yes.
after converting to ethane, we go to reaction 4. What do you call this kind of reaction?
Addition. Substitution.
Substitution reaction.
Reaction. What is the reagent that is needed there?
Bromine.
Bromine.
Not
Bromine.
Excess
bromine.
because we have replaced all the hydrogen ion. So there is excess bromine which is used there. The condition is what?
UV light.
Right. Perfect. Higher. About to go octane. No, the formula of octane is what?
C8. H12.
What is the formula for octane?
C8.
C8H18.
Alkane, you're going to know the past. That one.
C8H18.
CH88. So what is E? E itakuwa C what? If this one is C2H6, so what will be the C? Be what? C?
Excuse me, Chair.
C6.
C6H10.
H12.
It will be what? C6?
H10.
H12.
H12. It will be C6.
H10.
So that way, the other one gets the same, isn't it? C6H12. So which is now hexane. So the hexane, once it is oxidized, this one, don't bother about this one. This one, when it's oxidized, of course, this one should be C2H. This one should be, this is a mistake here. This one is CH2 Marangapi 6. And this will be hexane 1,6 diol. Hexane 1,6 diol. But that one cannot be tested like that. We are just going to give you the final answer. So here you see now we are oxidizing it again. When you oxidize it again, and we have the diol, we get hexane 1,6 diol. So the idea here is simply to get this product here. So for the examiner, the only thing that can be tested for you to know, here we are having hexane 1,6 dioic acid. So the idea was just to come up with this. So this is the first thing. This is the only thing you need to focus on. We have hexane 1,6 dioic acid, and we're having process 14, and we're getting nylon 6,6. So what is this process?
Polymerization.
And what is the reagent?
Pardon.
When you're using Linon 66, you use hexan 1,6 dioic acid. Right?
You'll be using alkanol.
No. So what you're doing. This one, I'm tackling formation of nylon 66. So you'll be able to understand it better. But of course, this one, we normally use hexan 1,6 dioic acid and hexan 1,6 diamine. I'll be still today after this, I'm finalizing on the formation of this polymer because they look complicated. I'll summarize it. So keep it here until we are able to finish up with that. So for now, I'll not talk much about this one because I have a session for it, which is like we're going to take like 10 minutes. So,
Okay.
Yes.
continue. We have process 6. We're having ethene being converted to an 1,2-diol. What do you call that one?
Oxidation.
Oxidation is the reagent is
Acidified potassium. 7 manganate, I think. 7.
acidified 7.
Reaction with potassium manganate 7. Acidify potassium manganate 7.
Or acidified dichromate.
6. Just stick to acidified potassium manganate 7 for reaction of alkanes. Then the condition there is what? Heat. The condition for oxidation is heat. So write it somewhere. It's not captured mostly in many books. So condition for oxidation is heat. Then when you have hexan 1,2, yes, I'm saying the reaction is the reagent is acidified potassium manganate 7, and the condition is heat. Sawa?
Okay.
Yes.
Finally, after we are through, I'll give you the questions and I'll also post the same flowchart and also the answers. So don't worry. But of course, again, because this is not again going to be posted in YouTube, as you can be able to repeat, listen again as you write down. Sawa? Because of time factor, because you see, today might be the last time that you're going to have a session. And if you don't listen, and if you waste a lot of time for something that you can easily repeat and follow it again and rewrite, you can now, you can say it back so that you are able to listen. So, ethene, now converting it into in process 6 to an 1,2-diol, we have said the reagent is
Acidified potassium manganate 7.
we use a pointer for that. Acidified potassium manganate 7. The condition is
Heat.
good. Then we have a 1,2-diol. We have process 7 to get it pterilene. So what is that process?
Polymerization.
And the reagent, what? What the reagent that required to form pterilene apart from the 1,2-diol? We have benzene 1,2-dioic acid. Again, today I'm dealing with formation of pterilene. So keep it here until we're to formation. I know they are a headache to you, but today we're to in a very permanent grave, rather that confusion must die a natural death. So I'll be able to summarize on that. Then we have ethene being converted to this. So what do you call this one? Which is this process one?
Polymerization.
Polymer is what?
Polyethylene.
Yes. Yeah, it is ethene. That is okay. And of course, we require ethene molecules. We require ethene molecules to be able to get that. We require it dog So normally we use this one is the ethene. Of course, if you're told what are what is the reagent for this polymerization?
Ethene molecules.
The condition we require high temperature and high pressure, and we also require a catalyst called the granata catalyst, also used in the polymerization of that. But normally in the books, we normally teach high pressure and high temperature. But of course, you know, nowadays with the way exam is being set, you may find an examiner telling you, apart from high pressure and high temperature, which is the other condition required for polymerization, we require.
Pardon, the other one?
Granata catalyst.
Granata is written as Z-I-E G-L-E-R
G?
Z-I-E.
Pardon.
I'm saying Z-I-E G-L-E-R dash. You can put an hyphen. Nata is N-A double T. That is Ziegler-Natta catalyst.
Double T?
Z-I-E Z-I-E-G-L-E-R hyphen N-A double T-A Ziegler-Natta catalyst.
Thank you.
Those are the issues of concern.
So must you specify the temperature and pressure?
No. For polymerization, these are just say high pressure and high temperature is enough.
Okay, thanks.
Only for this one. Sawa?
Yes. Yes.
Kujipea pressure kushinda ukiingia. Yes?
Catalysts.
Catalyst iko na-
Is it in process?
Is it in?
Process.
The process I said is polymerization.
Okay.
So can we continue?
A question, Mr. Mbaluka.
Yeah.
Is this catalyst used only on this polymerization of alkenes, or it's generally polymerization?
Alkenes, for polymerization of alkenes.
Thank you.
Then we have sugar to glucose. What is that one?
Fermentation.
Hydrolysis.
Fermentation.
What was your
Hydrolysis.
we first of all convert a complex sugar to simple sugar, that is hydrolysis. Then now sugar to crude ethanol due to naitanga fermentation. Don't confuse the two. Are we together? The only thing is that most in the books, they'll only say sugar to ethanol. But normally we don't really, there is the intermediate step. First of all, you hydrolyze sugar to glucose. Yes?
Rudia.
Nimesema hivi. First of all, when you're carrying out fermentation, sugar is first of all broken down to glucose. So that now glucose now undergoes fermentation. It's only that most of the books sometimes they have ignored that step of hydrolysis part. You know, according to, for those who do biology, you know, when you're converting glucose to sugar, that because you're combining two molecules to form one. But now when you're now converting sugar, it's just the reverse of concept of when you're combining two small molecules to form a large one. That is normally called condensation. And then when now you are converting the bigger molecule to smaller molecule, that is called hydrolysis. So sugar is first converted to glucose in the process of hydrolysis. Then now the glucose now undergoes fermentation. So process 11, the fermentation. Sawa?
Yes.
Then when you have, so what is the condition for fermentation?
Enzymes.
You can do yeast.
Yeast.
You know, the yeast, the one that gives out the enzymes. And what is the temperature there?
34 degrees. 37 degrees.
30?
37.
But most of the books look at the temperature of 30 to 40. That is wrong. For anybody who has done biology, tell you this being an enzyme will work best at a temperature of between 35 to 40. So talk about temperature of 35, temperature of 37, and it's okay. Sawa?
Yes.
Perfect.
Yes.
Don't start stressing yourself with the real name of the kama ukumbuke, just write yeast. That is enough. Crude ethanol to pure ethanol, process 12, that is what?
Fractional distillation.
Distillation. And then we have ethene. Ethene here in react na sulfuric acid to kapata ethane hydrogen sulfide. Then the ethyl hydrogen sulfide is now we undergo process 8 again to form pure ethanol. So what do you call that one? Process 8.
Process 8 is fractional distillation.
Fractional distillation is process 12. Crude ethanol.
Hydrolysis.
Yeah. So simply
Hydrolysis.
converting ethanol to
Hydration.
Hydrolysis.
that is hydrolysis. That's the keyword, hydrolysis. And I think that tick. Now we are through with that one. We go to next. We are summarizing everything. By the time to Maliza to record and anything about these things of organic. Haya. Tuko kwa ethanol hapa. Tuko kwa ethanol. Ethanol within. What is that?
Dehydration.
It is dehydration. What are the conditions for dehydration? What the reagents?
Concentrated sulfuric acid.
Concentrated sulfuric acid.
Condition is what?
170 degrees.
160 degrees.
160 degrees Celsius.
168.
Just listen, temperature of anything 160 to 180, but mention specific temperature. Temperature 160, temperature of 170, temperature of 180, 170, 160, that any day. That's it. Then we have ethanol to plus oxygen plus 2, G and H. What is G and H? What is that process?
Carbon dioxide and
Carbon
dioxide and water vapor.
Carbon dioxide and water vapor. If it was limited, oxygen ingekuwa nini?
Carbon dioxide.
Perfect. Ethanol plus sodium, we have combined M, which is what?
Sodium
Sodium
Sodium peroxide.
What is sodium peroxide?
Sodium hydroxide.
Oxide. Perfect. Then we continue. But remember, if it was yeah.
Sodium methoxide.
If it is magnesium hydroxide, and you need to know the formula of magnesium hydroxide, how to write it. Number 4, process 4, we are having ethanol to that one, whatever we are getting from that end. And I want to show you how to get the answers in the case umechanganyikiwa. Ukipewa kitu kama hii, sorry. If you're given something like that, kuja uikatie hapo. Ikatanisha hapo. Ukisha ikatanisha hapo, hii side inakuanga the alcohol, hii side inakuanga the alkanoic acid. So, ye unaangalia hii unaona iko na 2 hydrogen, 2 carbon atoms. So that becomes the alcohol is ethanol. Then the other one you just count 1, 2, 3. That's
3. Propanoid.
propanoic. So ukikuja hapa tu utaandika tu CH3, CH2OH. That is ethanol. Then the other one it becomes propanoic acid. Then we are adding.
Sir, please pardon.
Yeah. What's it?
Please pardon in the process 4.
4, we have ethanol here. Na tuko na this process 4 is what first?
Esterification.
Clarification.
So the reagent ndio tunataka kujua how do you get the reagent. Already hapo unajua uko na ethanol. So utakuja hapa uikatanishe katikati. Mahali umeona kuna COO, katanisha hapo katikati. This side gives you the alcohol. The alcohol already you have it, which is ethanol. So the other one, to get the name of the reagent, you just count the number of carbon atoms. 1,
2,
3,
2.
acid. Tunaelewana, eh?
Yes.
Good. So this one becomes the Q and X, which is then we have the process 5, whereby now we are trying now go the opposite of condensation of esterification is hydrolysis, and you get the corresponding product, which Q and X will be what?
Ethanol and ethanoic acid.
Ethanol and
Ethanoic acid.
Propanoic acid.
propanoic acid, perfect. So hii pia ester can be hydrolyzed, but hii achana nayo. It's the same. Instead of water, we can also use sodium, whereby we are still going to get the corresponding alcohol and alkane. But this one is not the syllabus, so this one achana nayo. We continue. We are through with this end. Tuende kwa hii side ingine. Kuna ethanol reaction 3 to ethanoic acid. What do you call that one?
Oxidation.
Oxidation.
Oxidation, we require what?
Oxidizing agent.
Reagent is acidified potassium.
Acidified potassium manganate 7.
Acidified potassium dichromate 6, and then we also require heat. Then we're having ethanoic acid plus sodium hydroxide reaction 8. What do you call 8?
Sodium ethanol.
Neutralization.
That is neutralized. The compound.
Cha, I have a question.
Let's ask.
Reaction 3, we used both potassium manganate 7 and dichromate.
In fact, acidified potassium dichromate 6 ndio inatumikanga kwa alcohol blow. Ile unasikianga kwa barabara being tested. So the alcohol blow is tested with the potassium. So if you inhale and it changes from green to orange to green, then you are confirmed ROH present. Because it means you have inhaled, you have taken a lot of alcohol that you are simply your stomach. So exactly that is a chemical that is normally used in the alcohol blows, and of course it's the one that so dichromate and potassium manganate 7 will work very well for both of them. Sawa?
Yes.
Good. Reaction 8, we have said that is neutralization, and compound M is sodium ethanoate. Then we have the sodium ethanoate. Now we are adding soda lime to get gas P. What is gas P?
Methane gas.
Methane gas.
Methane.
We are now preparing alkanes, whereby we use a sodium alkanoate plus any soda lime. So kama tungetaka ethane, tungetumia sodium propanoate. Kama ingekuwa propano, alafu upate propanoic acid, then you ongeze sodium, upate sodium propanoate, the gas will be ethane. But because this one is ethanoate, the gas is methane. Then now we undergo steam reforming.
Can you repeat?
I'm saying, when you're preparing alkanes, you use a sodium alkanoate to get the corresponding alkane less 1 carbon atom. Because remember, one of the other products that we form here is sodium carbonate. So the gas that will be formed have carbon atom compared to the alkanoate, which was sodium ethanoate, the part one of the carbon atoms If we want ethane, we are going to use sodium propanoate plus soda lime. Are we together?
Yes.
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 Methane, it undergoes steam reforming in presence of nickel catalyst, temperature maintained 1000 to get two product, which is what? Inajua mjui.
Hydrogen gas.
Hydrogen gas plus what? Plus carbon. Manufacture of listen, during manufacture of
Carbon 2 oxide.
kuna mahali mwalimu ulisikianga ukiambiwa we obtain hydrogen from natural gas. Natural gas is methane. So this is how we obtain hydrogen for using other process, using the steam reforming process, or rather what you call the steam catalysis. But that one again, I don't see anybody asking you that, but it's just good to know because it is captured somewhere in your syllabus that we obtain hydrogen for other process from what? Cracking of steam, or rather cracking of from natural gas. That's it. So that is it. Then we go here to connect calcium carbide plus water na tukapata gas F.
Excuse me, teacher. Umesema ni hydrogen gas and carbon 2 oxide ama ni carbon 4 oxide?
2 oxide. Nimeandika hata.
Oh, thanks.
We have calcium carbide plus water when they're getting gas F. What is gas F?
Ethane.
So then we have
Ethane.
reactions being converted to CH2. What is that reaction again?
Hydrogenation.
Hydrogenation.
It requires hydrogen gas. It also requires nickel catalyst or palladium and a temperature of 200 degrees Celsius. Process 9 is also what?
Pardon.
I'm saying gas F, this is ethane could be converted to ethane. What have we added? We have added what?
Hydrogen.
So that is simply hydrogenation. It requires hydrogen gas, nickel catalyst, and a temperature of 200 degrees Celsius. Process 9 is also what?
Hydrogenation.
That one is that we are using 1 mole of hydrogen, and we can say the reagent there is excess hydrogen. Anywhere whereby the reagent is more than 1 mole, you say excess. You see, like for this one, we are only adding 1 mole of hydrogen. Because remember here, ethane is C2. So we have added only 1 hydrogen. But for this one, convert this one to ethane, you require what? You require 2 moles of hydrogen. So in that kind of a scenario, this one you require hydrogen, this one you just.
Excuse me, teacher. Lazima uandike 1 mole, sijui 2 moles of hydrogen.
Hydrogen. In fact, that the excess, but that is the most, sometimes you can be given a question like that, then the examiner tells you to differentiate the reaction. Process 9, you're going to say in process 9, we are using excess hydrogen, or rather we are using 2 moles of hydrogen, while they're using hydrogen. Just say hydrogen. You don't have to state saying G 1 mole, 2 mole, all those kind of things. Just in case you are using more than 1 mole. Sawa?
Yes.
Sawa? Okay, then we have this one.
Yes.
We have this, tuko hapa, tuko na reaction 4, inatupea C2H4Br2. What do you call that one? What do you call that reaction? Reaction 5, this one.
Can you say halogenation?
Addition
Hydrogenation.
Addition of hydrogen halides.
Hydrogenation.
Hydrohalogenation.
Addition of hydrogen halide.
Hydrohalogenation.
We have added bromine. That answer there, simply addition. That answer is enough. The reagent that is added there is what?
Bromine. Bromine.
Hydrogen halide.
Bromine water.
Hydrogen halide.
Bromine.
This bromine. Angalia hii ni carbon ni mbili, hydrogen ni 4. Na hapa study kuna added in only. Are we together?
Yes.
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 This one is bromine. I want you to get that. The reason why nimeandika this one is bromine. Gas. But this one, what have we had?
Bromide.
Sasa hii ndio tumeongeza HBr. I want to show. Okay? If now you're adding hydrogen halide, you only have one halogen. But as two part of the halogen, it is important for you to be able to understand that. So get the difference. Because many students wakiona tu bromine, wanasema the reagent is bromine. So, and for these two reactions, they are simply called addition. Wachana na mambo mingi ya sijui hydrohalogenation, sijui iodination, sijui bromination, just call it addition. And there is no difference between, even if the examiner uses the word process or uses the word reaction. Just look at like if for example, it's now converting this one, ethanol to something. So even if we call this one process 4 or reaction 4, the answer still remains fermentation. It cannot change its name. So there are some schools of thought where people say that if now we are told it's a process, it is halogenation. When it's a reaction, it is addition. No, reaction and halide is simply called addition. Let me clarify something that many students don't know. Normally, for purposes of exam setting, we normally use the words reaction and process interchangeably. Normally for processes, it is normally used for those industrial processes that lead to formation of industrial products. For instance, hydrogenation is an industrial process because it is used industrially in manufacture of margarine. Polymerization is an industrial process that is used industrially to make polymers like polyethylene, like Teflon, plastics. Those are industrial processes. Fermentation, not fermentation is industrial process again. Iliyo ndio inatengeneza beer. Clarification is an industrial process which is used manufacture of fat and air fresheners. Somebody can even ask you, what are the uses of esters? Esters are what you call to use to make perfumes. That's why when you go to a cosmetic shop, you say, I want this kind of designer perfume. I want this perfume. And then you smell on it, you apply on it, then you say, this one smells magnetic. It's going to give me a magnetic attraction. So it's because it has a pleasant smell. That's why they say esters have a pleasant smell. That is now the technique that is used to make perfumes. Well, especially the ladies and whatever, if you're using a perfume, that smells nice. Air freshener that also brings about a nice smell. So that is what it's all about like that. But they can be used interchangeably. Like something like a reaction of ethanol and sodium, that would be an industrial process to manufacture what? But I'm saying it doesn't matter whether it is called a process or a reaction. Only hydrogenation. And I think I'm very clear about that. Now you're saying, students, you can use one page to summarize all the chemical reactions that can be tested in organic. Are you seeing it?
Yeah.
That's how you use the Octopus technique question model. Then, can you tell me? Yeah? I want you to answer this question. Name the fourth member, or rather, name to which class of homologous series does F belong? F belongs to which class of organic compounds?
Alkynes.
Alkyne. 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 Then name the fourth member of the homologous series. Name the fourth member of the homologous series.
Butane.
Butane.
Pentane.
The fourth member. Listen, the fourth member is pentyne because the first member is ethyne. We don't.
Oh, yeah.
So the first member is ethyne, second is propyne, third is butane, fourth is pentyne. That is the trick that most of you don't get. You can screenshot those answers. I think we have already passed through them.
Excuse me, sir, I have a question.
Yes.
What is decarboxylation?
Decarboxylation is this process here, which is whereby we're having now the formation of now alkanes. When like here we have sodium ethanoate. When you have sodium ethanoate, we react with soda lime. The product is sodium carbonate plus methane. Decarboxylation, you are simply removing the carboxyl group. So you are reacting sodium ethanoate with soda lime. The product are two, sodium carbonate and methane. Do we have a carboxyl group in any of the products?
Excuse me, sir, I have a question.
Let's do that. Have you got that, madam?
Yes.
Yes.
So we are saying we are removing the carboxyl group. It's simply the reaction between metal alkanoate plus soda lime. That is decarboxylation because the carboxyl group is removed. That one is really
Tell us the spelling of decarboxylation.
Unajua kuandika carboxylation?
Yes.
Anza na DE. Then
Excuse me, sir, a question.
Yeah. Ni kama vile unazamanga oxygenated, deoxygenated brand. So you talk about DE carboxylation. Then
I've got
somebody,
it. Thank you.
Yeah? Yes. I want to answer this question here. Kuna swali hapa number F. That maybe has not.
What is the work of phosphoric 5 acid?
What's the work of?
Phosphoric 5 acid.
In what?
In terms of in the carboxylic acids to alcohols to make aje.
Catalyst.
Concentrated acid.
Huh? No, that normally when you are talking about this, that's like when you may be able to get this, we have a process 3, like converting ethene to ethanol. I think I never noted that. I never understood this. This one is simply hydration, whereby we are simply adding water, we are adding steam. We are adding, we are reacting, India is steam, and we require phosphoric 5 acid.
Pardon the process.
Process 3 is hydration. It requires steam. It requires a temperature of 300 degrees Celsius. It requires a pressure of 60 atmosphere pressure. 60 atmospheres. 60 or 70, 80. It is 60 to 80. So 70 atmosphere, 80 atmosphere. Hapa pia tunatumianga phosphoric 5 acid as a catalyst. So that's of course, I think that is where you want it. So this one I'll be able to post how to differentiate methanol and pentanol. This one can only be used in terms of physical test. Remember the low carbon alcohols are very soluble in water, but the higher alkanols are insoluble in water. So this one, like for methanol and pentanol, you can each of them in separate test tube, then add equal amount of water. Then methanol will form a uniform solution, pentanol will form 2 layers. We can be taught to differentiate ethane and ethene. These now, like you can burn. Ethane burns with the blue flame, ethene burns with the yellow sooty flame. You can also bubble each of the gas separately through acidified potassium manganate 7. Ethene will decarbolyze purple acidified potassium manganate 7. Ethane, it will not decarbolyze purple acidified potassium manganate 7. So this one will just use the knowledge that I've given you on the qualitative analysis. And that is how you are able to summarize the entire organic.
I have a question.
Yes.
What about differentiating ethanol and ethene?
Ethanol and ethane, copy. Or ethanol and ethane, ethanol as ROH. How do you test for ROH? You use acidified potassium. Let me see. Ethanol and ethane, let me see. Ethanol and ethane, you can burn, of course, you can burn. You can burn each of them. Ethanol burn with a blue flame. Ethane burn with a yellow sooty flame because it's unsaturated. Then we also have, you can use acidified potassium dichromate 6. Ethanol will change acidified potassium dichromate 6 from orange to green, but ethene, the purple acidified potassium manganate 7, does not change from orange to green. Remember, potassium dichromate 6 only tests for ROH, so you use that one. You can also add sodium metal to each of them. Ethanol, there'll be bubbles of a gas, but in ethene, you cannot. There'll be no gas that will be formed there. You can. I'll be able to post more of the answers that can be captured there possibly in my Twitter handle, the answers for those questions. So I think now that's okay. I think people are tired. You are not able to listen to presentation. I think people are tired. I thought you are tired.
We are not tired.
Yeah?
Excuse me.
Yes.
You
The
see the
formation of
explanation
nitrous.
you
We
give
are not
for
tired.
We are tired.
and ethane.
You're saying what?
Electrochemistry. Electrochemistry.
Electrochemistry.
I was asking explanation
Yeah,
you
it's
give in
electrochemistry.
ethene and ethane. During the color exams, most people had written it and got it wrong.
I'm not getting you. Please, can you repeat what you have said? Hello? Somebody was talking and disappeared.
I was asking during the color exam, the explanation you give for ethene and ethane. Majority of people wrote exactly what you said but got it wrong. Or maybe there was like a mistake they made, a common mistake that you identified.
About the
like explain
there is the key word there that now if between ethane and ethane, you're supposed to say bubble each of the gases separately through acidified potassium manganate, or rather, you can put down, you're saying now, bubble each of the gas separately through acidified potassium manganate 7. In ethane, it will change from purple to colorless. Then in ethane, it will not change. So many students are writing, bubble the gas through acidified potassium manganate 7. That is wrong. Are you getting the point? That is now somewhere many students write.
Thanks.
Are you getting the point? That's a different thing. When you say bubble the gas, it means you are putting the gas of the two of them in a syringe and you are bubbling them through potassium manganate 7. Just like for example, if you are told even how to unaona kama hii methanol and methanoic acid. This is how you are supposed to say. Put methanol and methanoic acid, put 2 cubic centimeters of methanol and methanoic acid into separate test tube. And to each of the test tube, add sodium carbonate. In methanol, there'll be bubbles. In methanoic acid, there'll be bubbles. Whatever I'm saying,
Sure.
just listen, I finish. It's good you wait, I finish making a statement so that you can make an interruption. Whatever you are talking about separating, you have to bring about separately. Because you just say hard sodium carbonate, it means it can be a mixture to it. So you say you have to put each of these ones, like sodium carbonate and methanol, or rather methanol and methanoic acid. We know methanoic acid will react with sodium carbonate. You can also say put each of them in a separate test strip, then add 2 drops of acidified potassium dichromate 6. Methanol, it will change from orange to green, but methanoic acid, the orange color does not change to green, rather remains like that. It's good that you know you have to bring out the idea of separately. Yes, somebody was asking a question, Melvin Mwenda.
Thank you.
I was asking, is there a difference to say you pass or to bubble the gas?
Remember, ethene
Yes.
are gases, so you bubble, not pass. You bubble the gases.
Thank you.
Sometimes we don't penalize, even when you say hard. Hard means not to add ethene, but you know, any or alkanes from, or rather, or hydrocarbons, carbon 1 to 4 are normally gases. That just know that carbon 1 to 4 are gases. Then the others are liquids. So that is the, but even if you don't say, whether you say pass or whatever, you'll still be able to, we don't penalize you for wrong English, of course, in chemistry. But of course, it's always good to write something that makes a lot of sense. The most simple thing. I wanted to tell you how to prepare rubber and the soap and the polymers, but it seems people are tired.
No.
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 You want to continue to now? Can you give?
Yes.
I have a question.
Uliza?
Is it correct when we use acidified potassium dichromate in explaining theory?
But remember, acidified potassium dichromate 6 only tests for ROH and ROH alone. Of course, many books have captured it. Also tests for double bond. That's wrong chemistry. It will never score anywhere. It's only that the theory people used to mark it, but we have that thing has even been expunged from KLB. So it does in the school. Remember, acidified potassium dichromate 6 only tests for ROH and ROH alone. The only one that will test for ROH and double bond and triple bond is only acidified potassium manganese. And when you are adding those things, don't say the changes. Tell us now the acidified potassium manganese changes purple to color, and use the word changes, not turned.
Thank you.
Are we okay? Can you give me 2 minutes? And also I take some coffee and you also take some, then we revert back, we continue. I navigate through the summarization of those complex.
A minute before you go, sir. Excuse me, Chair.
Yes.
Before you go, there's this when you're given a monomer and then you're told to draw its a polymer. Mostly these monomers containing an alkyl in its structure. How do you go through it?
When are you told to given a monomer to draw the
Polymer.
then it contains?
And then the polymer, the monomer, like when you're told to draw the polymer of propionitrile.
I wish I could have. Yeah, I know. You're saying it's the guru. Let me see if I can be able to write it somewhere. Rather, maybe somebody can do it for us so that we can be able to get that. It's very easy. I'm coming to that because I'm dealing with the condensation polymer. So I think by that time it will be very easy for you to be able to understand that. So that is what I'm calling the net. Baba?
Okay.
Just I'm giving you 2 minutes, then we'll revert back. Wale umechoka endeni mulale because of the student who are requesting. I expound on that. Remember, I'm just giving things free of charge, and I'm just giving back to the community because I don't think I'll be able to get more time today. But because of the due to public demand, I'll see if I can get there before Friday. Maybe in the evening, we can tackle on the topic.
Mr. Baluka, you have to hand on electrochemistry because majority have a problem there.
That is what they have said.
Yes.
Yes.
I'll have to prepare it possibly.
They set aside to do electro.
Maybe on Friday or Saturday you can arrange a meeting for the same.
No problem. So make sure that you're
It's
ready.
not about in the evening, in
You
the
are
morning.
where we are following the session from. So we are going to little bit allow me to be able to take a cup of coffee and
okay.
I'll be back. Please,
Okay. Yes, sir.
But because of the power that you are talking now to continue, I have no option. Of course, currently I'll be making a call to know that. Always tell us where you are, maybe from you're following the session from.